All right, so let's talk about Kirchhoff's rules. Oops, there's an F missing. Kirchhoff's rules are rules for how current and voltage work in circuits. The loop rule is actually specifically the rule that talks about current, and the junction rule, I'm sorry, the loop rule specifically talks about voltage. The junction rule specifically talks about current, and these are very useful tools for solving circuit problems. You'll learn about Ohm's law in the next video, but Kirchhoff's rules are really the skills that you need to build because Ohm's law is a very simple calculation. So Kirchhoff's loop rule basically says that the total uh, voltage drop around a circuit loop is equal Sure, that worked. The total voltage drop around a circuit loop is equal to the voltage of the power source. The junction, well, let's start with the loop rule. So basically this means is that if I have an 8-volt power source, then every loop that I take is going to use up all 8 volts. That means along this path here, I'm going to use 8 volts, and along this path here, I'm going to use up 8 volts. That also means that along this path here, I have to use up 8 volts, and along this path here, I use up 8 volts. In the very last one, I have lots of different paths that I could take. I could take the outer path, and along that whole path through all of those total resistors, oops, I should have labeled it as 8 volts, it would use up 8 volts, and any other path that an electron took through this or a charge took through this circuit would use up 8 volts. So that means whatever the total or the voltage of each resistor is, it will add up to 8 if it's on the same loop. That does not mean, however, that say the voltage drop of these guys is going to add up to 8 because they're not on the same loop, so they don't have to add up to 8. Only something along a single loop has to add up to 8. So that's Kirchhoff's loop rule. And then we have Kirchhoff's junction rule, and I'll do that in a slightly different color so it pops out a little bit more. The junction rule basically says this. It basically says the current going into a junction equals the current coming out. So we'll do this in green, I guess. That basically means that whatever the current is right here, and I should have calculated this before I started, but whatever the current is going through the power source would be the same current that passes through the 1 ohm resistor because it hasn't had anywhere to split. But right here at the junction, it's going to split. So going through the two 6 ohm resistors, the current there will have to add up to be the same as what it was in the 1 ohm resistor. And you can see at this junction, they come back together, and once again will be whatever the total is. Going through this second circuit, the current along the 3 and 1 would have to be the same because it can't go anywhere, but it split right before it got there. So going through the 3 and 1, whatever that current is, plus the current that goes through the 4 ohm resistor would be the same as the current that's going through the 8-volt power source. And then through our final one, you can see that the current splits several times, comes back together several times. But among other things, the current going through the 8-volt, the 1 ohm, and the 2 ohm that I just underlined would all have to be exactly the same. The current along this bottom and this top would have to add up to be the same as that previous value. And then the current through the 5 and the 20 right there, again, would add up to be our total. This does actually mean that there are some patterns that we can look for in both current and voltage when we're talking about series and parallel components of our circuits. Specifically, the rule that we're going to look for voltage in series, the voltage is going to add up in series components. Because it's going through one and then the other, we're going to lose a little bit of voltage and then lose a little bit of voltage again, so we would add them together. So that would be something like the total voltage is always going to be equal to V1 plus V2 plus however many there might be. This only counts if it's only series, but that would be the case. If we're talking about parallel components, though, anywhere that it's parallel, the voltage is always going to be equal. And the reason for that is when it splits, we might lose some voltage there and some voltage there, but those are two separate loops that it would go on, so it would have to lose the exact same amount so that every loop that we have loses the total amount of the power source. So they're going to be equal there. So in that case, it looks something like VT equals V1, which equals V2. So that's our voltage rule. Our current rule is flipped. They are going to be equal if we're dealing with series. Because it's going through both of these resistors, whatever current passes through there has to be equal to the current that goes through there because there's nowhere else for it to go. So that looks like IT equals I1 equals I2. And then in parallel, it switches because we can see that the current can go either direction. So in that case, they're going to add up to be the whatever it was before. So we have IT equals I1 plus I2 plus whatever. So those are a couple different ways to look at Kirchhoff's rules. We'll be practicing them pretty intensely this week, but make sure that you feel comfortable with these ideas and that as you're keeping them in mind as you're trying to solve your circuits and thinking to yourself constantly, is my voltage going to be dropping because I'm going in series, or is it going to be the same because it's in parallel? And be thinking to yourself, is my current going to be adding up because it's split in two different ways, or does it have to be the same because it's going through the same area? And as you practice with this, not only will you get better at using the rules, it'll also start helping you to understand better how current and voltage are separate quantities. So thank you for watching, and I hope this helped you guys understand Kirchhoff's rules.